So this video is the second on the alcohols, and now I'm on to testing for alcohols. So there are three kinds of alcohols. There's primary alcohols, secondary and tertiary. We oxidize alcohols using acidified potassium dichromate, and the observation for this is the chromium will go from orange to green. And for anyone that's studying their second year of A-levels, it's the reduction of the chromium 6+ to the chromium 3+. But if you're in AS, you don't need to worry about that. So here's a table of the oxidations of the alcohols. So for the primary alcohol, when we add acidified potassium dichromate under distillation, we form an aldehyde. However, if we add the acidified potassium dichromate under reflux, then we get a carboxylic acid. For the secondary alcohols, if we add acidified potassium dichromate under distillation, we get a ketone. However, if we add it under reflux, there's no further oxidation, so we would also get a ketone for that. And tertiary alcohols, well, they're quite easy because they don't oxidize at all. So testing between aldehydes and ketones is done with either failing solution or Tollens reagent. So with failing solution, what this is a blue copper 2 ions in solution, and for you second year lot, that's hexaqua copper 2. Again, if you're in AS, don't worry about that. The observation for this is if there's an aldehyde present, a brick red precipitate will form. Obviously then, if it's a ketone, nothing will happen. Moving on to Tollens reagent, this is silver surrounded by 2 ammonias. For second year students, that's 2 ammonia ligands, and this is a linear structure with a bond angle of 180 degrees. If you're in AS, yes, you should know about the angle and the complex shape, but you don't need to worry about the ligand. So the observation, well, if an aldehyde is present, a silver mirror will form around the test tube. And that's all you need to know for testing for alcohols.